Okay, this is a continuation of section 1.6, MAC 1105. We have moved on to the last type of equation in this section, which are equations in quadratic form. And as we discussed in the last video, these are equations that have three terms, and the higher power is double the lower power. And we're going to use the method of substitution. And they just give us, there's several examples given here at the top, but I'll also be demonstrating examples by doing parts A, B, and C. So the substitution that you're going to do is always going to happen at the lower power. And it will only involve the variable and the power, not the coefficient. So we're going to start here by letting x squared be equal to u. And you can use any other variable. It's just a really typical to use u when doing substitution. So I'll just follow that format. Okay, so every time we see an x squared, we're going to put a u in its place. Be aware of the fact that the power that's double is going to have this particular expression twice if you break this down. For instance, x to the fourth is x squared times x squared. So for each of these x squareds that make up the x to the fourth, you're going to be putting a u in there. So u times u for the x to the fourth would be u squared. Then it's minus 8u minus 9. This equation that you've written, now that you've substituted the x squared right out of there, is very easily factored. So we can factor to solve for u. And with these problems, you're going to substitute the difficult term right out of there at the beginning of the problem, and then you're going to resubstitute again at the end, as I'll demonstrate. So factoring this, you would have a u here and a u here. Then using this guess and check method, we would be breaking up the -9 in the back. We broke up the front term in the front positions. We're going to break up the 9 now, but we're going to try and break it up in a way that when you add those numbers, you're going to get a -8. So that would be 9 times 1. If we want this middle term to be negative, we're going to need that 9 to be negative and the 1 to be positive. Now let's check this real quick. U times u is u squared. U times -9 would give us -9u. And then the other portion of this middle term would come from right here, positive 1u. And those two together add up to -8u. So we've got the right numbers, the right signs, and then of course that last term times that last term is where that constant comes from. So just checking real quick, if you're going to use guess and check, foiling in the middle of the problem, mentally foiling to check that you have everything in the right position is important. Okay, so we also have the equal sign and the 0. We can get the solutions for u, which will not be the final solutions. So we now know that u is equal to -1. And when we set the other factor equal to 0, u minus 9 is equal to 0. And we bring the -9 over here. We see that for this equation, u is equal to +9. So far, we know the two values that u is equal to, but you were asked to solve for x. Therefore, you must bring x back into the equation. Well, if we said at the beginning of the problem that u is the same thing as x squared, we allowed x squared to be substituted by the letter u, then we can do that same substitution again. Anywhere that we saw an x squared in the beginning of the problem, we put a u. Well, right now, anywhere we see a u, we can put an x squared because they're equivalent. So we're going to take these two equations we have, u is equal to -1, and put an x squared right back in its place. So that means we now have x squared is equal to -1, and we can solve that to get two solutions. We know we're going to get two solutions because it's a second degree equation. And we also have this other little equation. U is equal to 9. Well, u is equal to x squared. So that gives us this equation. When you solve each one of these, you just use the square root property. Take the square root. Don't forget, a square root is an even type of root. So when you take the square root on the numeric side, you need to report both the positive and the negative root. So here we removed the square. Here we're going to report both the positive and the negative root, and we know this as the definition of I. So we have two imaginary solutions here, positive I and negative I. Here, when we go to take the square root, that forces us to take the square root here as well. Don't forget, report both the positive and negative root. That gives us x is equal to plus or minus 3. And those are our four solutions. We have plus or minus I, and you can list them separately if you'd like. That's what my math lab will probably make you do. They'll probably make you do I, or what, negative I, comma, negative 3, comma, positive 3. Sometimes they'll only ask for the real solutions. And if they say just give us the real solutions, then you would just state plus or minus 3. If they want all solutions, then you give all four of them. You can separate them and list them individually. Moving on to part B, we're also going to do substitution, only now the middle term is without the coefficient, because that's what you want to do the substitution for, is x to the 1/2. So we're going to let u be equal to x to the 1/2. Remember, x to the 1/2 is the same thing as square root of x. It's just that right now, to show you that this power was double this one, I wanted you to recall that square root of x is the same, can be written as x to the 1/2. So starting this problem over here, we have x, and let me point out to you why you're going to have u squared here. Okay, x to the power of 1. That is the same thing as x to the 1/2 times x to the 1/2. You're always going to see that there's 2 of the letter that you're using to substitute in this for the highest power. X to the 1/2 times x to the 1/2, that x to the first can be written like this, because when you write it as a product, you add the powers. 1/2 plus 1/2 is 1. That's called the product rule for powers. So really, inside of a x to the first degree, there are 2 of these. And in for each one, you're going to put a u. You're going to put a u here and a u here, resulting in u squared. Then the middle term will be minus 8. That for that term right there, square root of x, which is x to the 1/2, a single u, plus 12. So you end up with this really simple quadratic equation, which you can then factor. And if we split up the u in the front position, and then we think of some ways to 2 numbers that we can multiply to get 12, but that will add to give us 8, that would be 6 and 2. So 6 and 2, last term being positive means that these signs will both be the same. This is what they'll both be. That's a good rule to know. Then we're going to solve for each of the equations we're creating right now out of the factors. So this will give us u is equal to 2. But remember, those are not the final solutions. This will give us positive 6. And don't forget to re-substitute at the end, just like we did in the previous problem. You have to do that resubstitution so that you're bringing x back into the problem and actually solving for x rather than u. But it starts with solving for u, and then where the u is, we're going to put whatever we called the substitution. U is the same thing as x to the 1/2. This says u is equal to 2, so this will be equal to 2. If you prefer now to, rewrite it as square root of x, you can. This is the same thing as this. This is just one way to write square root of x. This is another way to write it. Maybe you are more comfortable with this. It's up to you. And then the other equation, u is equal to 6, would be x to the 1/2 is equal to 6. Again, you can write it in its square root form if you like. Now solve. Okay, so when you square both of these, you're going to square this, you're going to square this. So one of your answers is x equal to 4. And when you square both sides of this to get rid of the square root, you get x is equal to 36. Okay, that takes us to the last problem, which has negative exponents. Again, we're going to do the substitution right at the middle term. We're going to let u be equal to x to the negative 1 just to get rid of that weird type of power. Don't forget that inside the term that has the higher power, you're going to have two of these. You're going to have this multiplied by itself. So x to the negative 1 times x to the negative 1 is the same thing as x to the negative 2, because when multiplying like bases, you add the powers, which means that this can be written like this. And in for each one of these, you're going to put a u. That happened for every single example on this page. So that first term would be u squared based on the substitution that we're using in this problem. And then that would be minus u minus 6. That would give us this equation. We can factor it as we have the others. The numbers that would work here for the split up of the negative 6 would be negative 3 and positive 2. And you know, it's up to you. You can put the negative 3 up here and the 2 back there, same thing. Let's make little equations with our expressions containing u, the factors. The other equation would be u minus 3 is equal to 0. We would bring this 2 over here, resulting in negative 2. These are semi-solutions. They're really not the final solutions yet. Okay, now resubstitute. Bring that x back into the problem. We said in this problem that u is the same thing as x. We allowed u to be equal to x to the negative 1. That was the arbitrary assignment that we made. And so if we rewrite what we have right now, that u is equal to negative 2, well, u is equal to x to a power of negative 1. And that u is equal to negative 2. That's one equation we're going to solve. The other equation is u is equal to 3. But u is x to the negative 1 according to our substitution at the beginning of the problem. So u is equal to 3. And then try to recall what x to the negative 1 really means. Anything to a negative power means that it's a fraction. Just like you have to understand different ways to write radicals. Radicals mean that you can write them in exponential form, but that exponent's a fraction whenever it comes from a radical. Whenever you see that the exponent is negative, that really means that it can be written as a fraction. You can write it either way, and most students need to write it as a fraction to understand how to move forward in the solving process. So this is the same thing as 1 over. It's always 1 over, and then this base to this power of 1. Only now the power is positive. That's how you go from a negative exponent to a positive exponent, by dragging this base down to the denominator and rewriting the power in its positive form. So this is just 1 over x is equal to negative 2. And when you solve that, all you have to do is cross multiply. Okay, you can cross multiply right here. You can just go 1 is equal to negative 2 times x, and then you can divide that negative 2 right off of there. So that for this answer right here, you end up getting, those negative 2's are gone, you end up getting x is equal to negative 1/2. Now that is a full, complete solution, because you're actually talking about x in that answer. Likewise, this one would be 1 over x equal to 3. You could cross multiply here, resulting in 3x is equal to 1. This x is now up here. Then you would divide by 3 on both sides and end up with x is equal to 1/3. And that is a full and final answer. Okay, that completes section 1.6.